Hi guys, this is Ms. Igo. Welcome to my classroom. In this video, we're going to be discussing simple and compound interest. Simple one-time interest can be found by using the formula I equals P times R. I is going to represent the interest. P is the principal amount, which is the starting amount, and R is the interest rate in decimal form. For example, if we have 3%, when we put it into this formula, we need to change it to a decimal, and we do that by moving our decimal place 2 places to the left. So 3%, if I move the decimal 2 places to the left, would give me 0.03. That I is equal to P times R just finds the interest. If we wanted to find the entire amount that's owed once interest is earned or accrued, then we would use this formula. A represents the end amount, the total amount, which is simply the principal plus the interest. And remember, the interest is found by multiplying P times R. That's how we get this. So this is the principal plus the interest. And if we factor the P out of this, we get P times 1 plus R. So we would use this formula, P times 1 plus R, and to find the total amount owed or the amount earned once the interest has been determined. To know which of those two formulas you need to use, you're going to have to see what is being asked. In this example, it says a friend asks to borrow $200 and agrees to repay it in 30 days with 5% interest. How much interest will you earn? So the question is only asking for the interest, not the total amount that needs to be repaid. So we're just going to use that simple I is equal to P times R in order to find the answer to this question. So our interest is equal to the principal, and in this case it's $200. Remember, the principal stands for the starting amount, times the rate, which is 5%. Now remember, every time when we put this into our interest formula, we need to change that percentage to a decimal, meaning we have to move the decimal 2 places to the left. So that would give us 0.05 or 5 hundredths. And then we would put that in our calculator. Once we put it in our calculator, we find that the interest is $10. So you will earn $10 if your friend borrows $200 and pays it back with 5% interest. The 30 days has no bearing on how much interest you'll earn because you're only calculating the interest one time. If the question had instead been, how much money will your friend need to pay you back at the end of the 30 days, we would use the second formula that I showed you earlier, which is A is equal to P times 1 plus R. Because your friend is going to need to pay you back not only the interest, but the amount that they borrowed to begin with. So the total amount is going to be P, or the principal, what we started with, the $200, times 1 plus R, or the rate. And the rate in this case is the 5%. So 1 plus 0.05. All right, and if we put that in our calculator, we would get $210, which you could have also figured by just taking the amount that you started with, the $200, and adding the interest that you found by doing the principal times the rate. Suppose your city is building a new park and issues bonds to raise the money to build it. You obtain a $10,000 bond that pays 3% interest annually that matures in 5 years. How much interest will you earn? This problem is different because it is earning interest over time. Let's look at the formula that we would need to use for this situation. For simple interest over time, we would find the interest, I, by multiplying the principal times the rate times time. That's to find just the interest, and then to find the total amount at the end, we would multiply P times 1 plus R times T. So again, this is simply the principal plus the interest. Notice that the time is in years. Looking back at the problem, the question asks, how much interest will you earn? So once again, we're finding the interest only. And the interest is found by multiplying P times R times T. Okay, so our interest is the principal. In this case, it's $10,000. Times the rate, which is 3%. And remember, every time we're doing these interest formulas, we need to change the percent to a decimal. Move it over 2 places to the left, so we get 0.03 times the time, that's in years, and they've given it to us in years, so it's 5 years. So we'll multiply that times 5. And we'll put that in our calculator. And once we put that in our calculator, we find that the interest is $1,500. Let's look at another example of simple interest over time. Bob invests $12,000 into an account at an annual rate of 0.3% simple interest for 19 months. How much will Bob have in the account at the end of the term? They're wanting to know the total amount in the account at the end of the term. So we're going to use A is equal to P times 1 plus RT. So the total amount in the account is equal to the principal, $12,000, times 1 plus the rate. Again, we need to change it to a decimal. This time it's 0.3, so we need to move it 2 places to the left, which would be 0.003. Times the time, and remember the time should be in years. Well, they've told us that the amount is going to be in the account for 19 months. So we have to put it into our formula in terms of years. Since they've given it to us in months, we have to relate it to years, and there are 12 months in a year. So that would be 19 out of 12 months. So it's over a year, so it's 19 over 12. Anytime you're given a term in the number of months, put it over 12 because there are 12 months in a year. Now we can put this into our calculator. If you need some help on how to input this information into the calculator, I have uploaded a couple of videos that show you how to do that, and I will put links to those in the description. And once we put it in the calculator, we find that the total amount that Bob will have in the account at the end of the term is $12,057. Simple interest, or the type of interest that we've talked about so far, is calculated only based on the principal amount. To explain compound interest in a simple, basic way, let's just assume that you have $100 and you're going to invest it in an account which is going to pay you interest monthly. We also need to assume that you're going to leave the money in the account without withdrawing any. If you invest that $100 in the account, let's say at the end of the month, you're paid $5 in interest. So now your new balance is $105. The next month, when the interest is calculated, it's going to be calculated on the new $105 balance, which means you're going to earn more money in interest. That's compound interest. The compound interest formula is A, which again is the amount in the account, is equal to P, which once again is the principal, times 1 plus R, which is the interest rate in decimals, over N, so this is a new letter, the N in both places, so we have N in the denominator of our fraction, and then we also have N in the exponent. In both of those places, that represents the number of compoundings per year. For example, if it is compounded monthly, then N would be 12. If it's compounded weekly, there are 52 weeks in a year, so N would be 52. If it's compounded yearly, of course, N would be 1, or semi-annually would be 2. So there's lots of different possible compoundings per year. And then T stands for the number of years. So this example says, suppose you deposit $4,000 in a CD paying 6% interest, compounded monthly. How much will you have in the account after 10 years? All right, so the formula again is A is equal to P times 1 plus R over N to the NT power. Some books or videos or different things that deal with this formula sometimes use other variables to represent these terms that we're talking about, but the formula is the same. Okay, so the total amount is going to be P, which is the principal, in this case is $4,000, times 1 plus our rate that needs to be changed to a decimal. If I move the decimal two places to the left, that gives me 0.06 over N. Okay, so N is the number of compoundings per year. This says that it's compounded monthly, so the number of times per year would be 12. So I'm going to put that in the denominator, and then I'll also put it up here in the exponent. Times T, which is 10 years. Okay, so that's 10. If you want to, before you put this in the calculator, if you just wanted to multiply that separately, of course that would be 120, or you can put it in the calculator as you're raising your exponent to 12 times 10. Once again, I have a video that shows how to put this in the calculator, and I'll link that in the description. So now let's put it in our calculator and see what we get. So after 10 years, you will have $7,277.59 in the account. I'm going to do one more example for you. Suppose you take out a loan for $2,000 charging 4.25% interest, compounded semi-annually for 3 years. How much will you owe at the end of 3 years? So once again, we're going to use the compound interest formula. A is equal to P times 1 plus R over N to the NT power. So the amount in our account is equal to 2,000 times 1 plus our rate. Move our decimal 2 places to the left, which would give us 0.0425 over N, which is the number of compoundings per year. Semi-annually means twice a year, so that would be a 2 in our denominator and a 2 in our exponent, times T, which is the number of years. And in this case, it's 3. Once again, if you want to multiply that together, that just gives us 6. We can raise it to the 6th power. And let's plug all that into our calculator. And after 3 years, the total amount that you owe is $2,268.94. If you enjoyed this video, make sure to subscribe to my channel, and if it helped you, please be sure to share it with your classmates. Thank you for watching.